TRANSINO is required to find a suitable site to develop a transit hub that would benefit the McMaster University community. The transit hub would be home to not only the LRT, but also the GO Bus and Hamilton Street Railway buses. Three potential sites were found, and a framework was developed to narrow down to the final selected site. The framework involved several steps, as you can see in the visual on the right. Of the three potential sites, the team selected Parking Lot I. There were several benefits to selecting Parking Lot I. Firstly, we would free up valuable space that can be redeveloped to house students and staff, whether it be a residence building or an academic building. Secondly, we would conceal traffic incoming to campus from Main Street. And one thing I want to note is everything we're doing is aligned with the campus master plan update. So everything is following the university's vision for the campus in the future.
TRANSINO will determine sustainable and prosperous road by using three pillars of sustainability. The three pillars of sustainability include environmental, economic, and social. In addition, the innovation of the project, such as new bike parking spaces, green building design, and sustainable material use, are considered in our project. Renewable energy is used for building to prevent heat loss and lower environmental impacts. The products such as concrete, wood, and glass are considered for recycling use.
In order to efficiently access the transit hub, it was deemed that an intersection from Coots Drive into College Crescent would be required. By doing so, this is aligned with the university's vision of moving towards being pedestrian-focused along portions of campus, including University Avenue.
Since the whole project will be constructed based on the previous facilities, the change of vehicles types and volumes will cause the redesign of the pavement types and properties. Rigid pavements are recommended for the reconstruction because it can separate the stress evenly to the base layer of the pavement, so that the pavement will not crack easily under heavy buses. The final design thickness is 9 inches by using of Ashton method.
With the adjustment with new pavement design, a stormwater management design was developed to examine the new demand for stormwater, and according to the design changes and the different methodologies, to achieve the sustainable goals and to prepare for the extreme weather conditions. Facilities like rain harvesting rooftop was introduced in the proposed transit hub as a potential infrastructure that could be used inside the hub to save stormwater and be used as grey water.
The purpose of this chapter is to create a transportation model to analyze the impact of modifications on the project's transportation aspect. Building a transportation model aims to provide organized estimations that can be analyzed to identify the consequences of transportation efforts. Overall, the synchron and sim traffic model shows that the newly built intersection will not generate traffic congestion in normal conditions after the route change. The goal of this chapter is to determine what TRANSINO can achieve in terms of environmental assessment and how big of an impact all the changes will have on the current situation, to offer a real-world reference for any judgments and actions that may be required. The group will collect the data and provide estimations. The study and results are based on documents provided by the Ontario government. Once the report is finished, it will be submitted to the related department and will be transparent to the citizens that may be affected by the project.
The design structure was proposed to be located at west side of Lot I in McMaster University, and the dimension is 35 meters times 70 meters. The rest of the parking lot will be converted to terminal stops for GO buses. We chose steel over concrete because steel has more lightweight components and higher strength-to-weight ratio. It has higher ductility and reliability. It also offers an option of being prefabricated, which makes it faster and easier for construction process and can reduce cost. In terms of the building exterior, we utilized curtain wall after consideration of criteria such as energy efficiency, structural stability, and appearance. Although curtain wall has a higher installation cost and material cost, it has much more benefits, such as allowing lights to shine into the building, providing additional sound insulation from the outside of the building, reducing water and moisture penetration into the building, and providing a unique and more elegant look to the building facade. The structure is aimed to provide a better service for users of Go buses and the future LRT system. The limitation of the structural design is we didn't consider foundation, building science, and other integral elements of the building such as HVAC and the mechanical system.
All the essential elements of the structure design process has been determined in the structure analysis process. The selected beam section is W330 by 33, the selected girder section is W460 by 97, and the selected column section is W330 by 162. All structure elements are selected based on factored resistance, industrial familiarity, and the weight of those elements. The design process is based on the reasonable assumptions and the guidance of the CISC Steel Handbook 12 editions. All adjustment and the selection of the section are strictly followed by the CISC Steel Handbook.
To save cost, all of the steel structural components are prefabricated, and the total adjusted construction cost is around $7.8 million, with the assumption that the cost of HVAC, elevator, foundation, mechanical system, plumbing, and other integral elements of the building is excluded.